Welcome back to So What Does That Mean? The podcast where we break down engineering, planning, and construction in plain English. I'm Brendan, the engineer.
And I'm Joanne, the non-engineer. If you're a developer, builder, homeowner, or just someone trying to make sense of the construction world, you're in the right place.
Every episode, we take a topic that costs people real money, real time, and real stress, and we unpack it so you actually understand what's going on, why it matters, and what you can do about it.
No jargon walls, no lectures, just practical, common sense advice from the people who see these problems every single day. So, Brendan, today we're talking about retaining walls. And I know people hear retaining walls and their eyes glaze over. But do you reckon this is one of the most underestimated costs in residential construction?
Yeah. And this is one of those topics where I genuinely see people lose tens of thousands, sometimes hundreds of thousands of dollars, because nobody explained it to them up front. So let's get into it.
All right, Brendan, before we go any further, I want to hit people with some numbers because I think a lot of people hear retaining walls and think we're talking about a couple of $1,000s. So let's do a reality check. What do the numbers actually say?
Okay, let's start with the big one. The number one cause of retaining wall failure in Australia, and this is across every study, every engineer, every builder who's honest about it. It's drainage failure. Not bad materials, not bad construction, drainage. Water builds up behind the wall. It creates what we call hydrostatic pressure, and the wall moves. It's as simple as that.
Okay, and how much worse does water actually make things?
Here's one that surprises people. Waterlogged soil weighs up to 50% more than dry soil. So if you've got a wall that was designed for dry conditions and suddenly it's retaining saturated ground, you've just increased the load on the wall by double. That's an enormous difference. That's the difference between a wall that stands for 50 years and one that starts leaning after 2.
Okay, so how much are we actually talking about in dollar terms? Like, give me a range.
For a basic 1 meter concrete sleeper retaining wall, so they're the ones that have your steel I-beams that go vertically upwards. You've got your foundations, which are typically pier foundations, and then you've got your concrete sleepers in between. Looking at roughly $300 to $600 per linear meter installed. It sounds manageable, right? But here's the kicker, and this is the stat that makes people's jaws drop. If you double the height of a retaining wall, you roughly triple the cost of construction. Not double, triple, because the lateral earth pressure increases with depth, so everything gets bigger. Deeper piers, heavier reinforcement, thicker sleeper sections, more robust drainage. A 2-meter wall on a residential block can easily cost $800 to $2,000 plus per linear meter. And on a sloping subdivision site, where you might see 100 meters of retaining at various lakes, you're looking at $100,000 to $500,000 that might not have been in anyone's feasibility study.
$500,000 on retaining alone?
Just on retaining. And here's another one that blows people's minds. In the state of Victoria, housing defects cost nearly $1 billion every year. 1 billion, not million, not hundreds of thousands, 1 billion. And almost 80% of housing insurance claims in Victoria are attributed to damage caused by soil movement. That includes ground that shifts because retaining wasn't done properly or wasn't done at all. We're not talking about a niche problem here. We're talking about the single biggest cause of structural damage to homes in this country.
Okay, so when someone says, oh, it's just a retaining wall, we'll sort it out later, what are they actually risking?
They're risking exactly that. They're risking being part of that billion-dollar defect statistic. And the cruel irony is that the cost of getting it right up front, proper engineering, proper drainage, proper construction, is a fraction of the cost of fixing it after it fails. We're talking maybe $600 to $1,500 of engineering design versus tens of thousands, sometimes over 100,000 to demolish and rebuild a failed wall. Fix the damage it caused, deal with the council, deal with the neighbour whose property it affected. It's not even close.
Okay, and how many walls out there are actually non-compliant, like without building approvals or engineering?
Look, there's no national database tracking this, but I can tell you with decades of experience, the number is staggering. In older suburbs, it's estimated the majority of retaining walls over 1 metre were built without engineering or council approval. They just went up, bloke with a bobcat and some sleepers. And for a while, some of them are fine, but they're ticking time bombs. The moment drainage fails or the soil gets saturated from a wet season, or someone builds a house with footings within the zone of influence of that wall, that's when it all comes undone.
You mentioned the zone of influence. Can you explain that quickly? Because I think that's another one people don't really understand.
Sure. Every retaining wall has a zone of influence. Every structure has a zone of influence. Basically, an invisible wedge of ground behind and below the wall that's affected by the lateral pressure. If you put a house footing, a driveway, a swimming pool, or any other structure that creates a load inside that zone without accounting for it in the design of the retaining wall, you can destabilize the wall, or the wall's loads can damage your structure. And I see this all the time in subdivisions where the developer builds a retaining wall and then the homeowner comes in and puts their house pad right next to it without getting independent engineering advice. Nobody told them about the zone of influence. Nobody told them the wall and the house need to be designed together. And by the time the cracks appear, and they always do, it's an expensive problem.
Wow, that's terrifying. So, just to recap the numbers for anyone who's driving and can't write this down, drainage failure is the number one cause of wall failure. Waterlogged soil is 50% heavier than dry soil. Doubling a wall's height triples the cost, and 80% of housing insurance claims in Victoria are from soil movement. And house defects in the state alone cost $1 billion a year.
That's the reality. And the frustrating part is that almost all of it is preventable with proper engineering.
So let's start with the basics. Why are retaining walls such a big deal? Most people think of them as just a wall holding back some dirt.
Exactly. I mean, retaining walls are engineered structures. They are resisting lateral earth pressures, hydrostatic pressure, surcharge loads. You need to be able to calculate all of those loads that will be applied to the wall and design a wall that will resist that site specific case. The moment you cut into a slope or fill a site, you're creating forces that need to be managed. In southeast Queensland, especially with our reactive clay soils, the engineering is critical. If you get it wrong, you will get movement, cracking, and failure. A retaining wall isn't just a garden feature. It's structural infrastructure. In subdivisions and in residential properties, they are generally in confined spaces. When the retaining wall goes in first and the house gets constructed within close proximity to it, if that retaining wall fails, how do you go back easily to go and repair it? There are significant costs just to access the wall to be able to get in to repair it.
So when does a retaining wall become a council or a certification issue? Like, can you just build one without telling anyone?
Well, no. In Queensland, for example, any retaining wall over 1 metre generally requires a building approval and engineering certification. Below 1 metre, it's generally classed as a landscape wall or a landscape feature. Um, as soon as you get over 1 metre, it's now an engineering structure. Some walls under 1 metre can cause massive problems if they're poorly designed or interact with other structures like a house footing within the zone of influence. You could have a wall that is 0.5 metre high, but if the wall is 0.5 metre high and is actually beneath your house and forms part of your engineering foundation, then that wall is going to take loads from the house structure above it. So therefore needs to be engineered and treated as if it is part of your foundation. Many councils are now cracking down on unapproved retaining walls, especially in subdivisions. They're placing restrictions. We've seen restrictions on retaining walls in subdivisions. Some retaining walls, they say, cannot go over 1.2 metres. And if it does go over 1.2 metres, you've got to have special considerations, special approvals to do so for the entire subdivision. There's a bit of a trap with retaining walls as well. A lot of them are close to boundary walls. Boundary fences generally get fixed to the top of retaining walls, which is a bit of a trap because the retaining wall itself has to have a drainage layer behind it to be able to, dispose or reduce those hydrostatic pressures. But if you were to put a boundary fence up, your boundary fence should be sitting on your boundary and the boundary fence line. So to do that, you need access to the neighbour's property to be able to put adequate drainage behind it. It's a lot easier to build retaining walls in that fashion if there are no houses around and you're building a subdivision from scratch, because technically the subdivision the lots haven't been established yet, so you don't need your neighbour's approval to do so.
You mentioned subdivisions. How often do retaining walls blow out budgets in land developments?
This is where it gets really expensive. In undulating or sloping sites, retaining can easily be $100,000 to $500,000 plus, depending on the scale. Developers often underestimate this because their feasibility study used flatland assumptions or a desktop geotech report. The real cost only becomes clear once you do a proper survey, geotech, and civil design. And by then, you've already bought the site. Retaining walls can expose significant issues under the ground. For example, rock. If you're trying to drill pier foundations of a basic concrete slipper retaining wall into rock, it can be significantly more expensive than what the original estimate may have been. Another issue may be the type of soil itself. If there's a high clay content in the soil and the soil generally holds water, then the soil under, standard rainfall events may become significantly heavier than what a standard site could be. This is exactly why we encourage everybody to do their engineering due diligence early on while you're undertaking your feasibility study, rather than having it as an afterthought.
What about builders doing house and land packages? Do they get caught out too?
Absolutely. Many builders quote a standard site cost that assumes a flat or nearly flat pad. The moment there's a fall across the block, retaining is needed. Homeowners sign contracts, not understanding that the site works are provisional, meaning that the costs can actually blow up. The classic scenario: buyers purchase a sloping block in a new estate, gets a $30,000 site cost estimate. Actual retaining plus earthwork comes back at $80,000 to $120,000. This is why we always recommend getting independent engineering advice before signing a building contract on a sloping site. There's three main types of retaining walls in terms of building materials. Make sure that when you're talking to your builder, that you understand that the material that they're going to be using. You've got timber sleepers, concrete block or concrete Besser block walls, and you've got board pier walls. So they're your concrete sleeper walls. Sometimes there are boulder walls as well. All of these come with different costs up front and a different level of maintenance cost. You need to understand this from the start, because if you get a boulder wall, for example, that may look nice with the features of your house and the type of look that you're going for, you might be up for hundreds of thousands in maintenance later on if the wall was to move or dislodge, or it was in a zone of influence of another structure that you're not aware of. So you should be well and truly aware of this for purchasing any house and land.
Okay, so what's the practical takeaway? What should someone actually do if they're looking at a site with any slope at all?
Step 1, get a proper site survey, not just a real estate boundary plan. Step 2, get a geotech investigation. Understand your soils and your rock profile. Step 3, engage a civil and structural engineer to assess retaining requirements before you finalize your design or budget. Step 4, factor retaining into your feasibility from day one, not as an afterthought. The common sense message: if you can see a slope, there's a cost attached to it. The question is whether you discover that cost before or after you've committed your money.
All right, so if people are listening to this and thinking, that sounds like me, what's the one thing they should do right now?
Pick up the phone, talk to a qualified engineer before you commit to anything. Not after, not when the problem shows up, before. That one conversation could save you more money than you'd believe.
And that's the JCE difference, right? You're not just ticking boxes, you're actually trying to help people avoid these traps.
That's exactly it. We've built our whole practice around giving people clear, practical, common sense advice before the problems start, not after.
I love it. All right, if you found this episode helpful, please subscribe, leave us a review, and share it with anyone you know who's building, developing, or renovating. It might just save them a fortune.
And if you've got a question or a topic you want us to cover, just drop us a message through any of our social accounts or hit us up through JCE. We read everything.
Thanks for listening, everyone. Until next time.
See you on the next one.